In this lesson, we are summarizing the ambiguous case of the sine law. So our goal here is that given an angle, the side across from it, and one other side, we can decide if the information will form one triangle, no triangle, or two triangles. And then you can solve the triangle if it has one or two solutions. So from our investigation, we found that if we know one angle, the side across from it, and one other side, so in my diagram here, I have my angle, the side across from it, and one other side's value, we have the potential for this ambiguous case to happen. It could be that if the side across from the given angle, so in my diagram, my given angle is A, the side across from it is little a, if it is something than the other side, there would be only one solution to the triangle. So if side A ends up being longer than side B, then there's only one solution there. If it's bigger or longer, we can't make two triangles from that. If the side across from the given angle is smaller than the other side, okay, smaller than the other side, but bigger than B sine A, so the other side times the sine of the given angle, there would be two solutions to the triangle. So what happens is that you have, let me do that in a different color. So option, I should have done these in different colors. If your side is shorter, you could have something that looks like that for side A, but it could swing this way, making this a little isosceles. These are isosceles triangle here, but that's not really the triangle at all that we're talking about. But you have the two different triangles where angle B could be acute, so I'll call that B1, or angle B could be obtuse. All right, and then if the side across from the given angle is something than something, the triangle cannot be made and there's no solution. So that's the case if the side across from the given angle is smaller, and I'm doing this one in red so I can show that in a different color on our diagram. If it's smaller than B sine A, so the other side times the sine of the angle, then what happens is it dangles. It's not long enough to even make a triangle out of that. So these things here are the things I'm showing in the green on the diagram. All right, so given the information for the triangle, determine if there's one solution, two solutions, or no solution. So here's angle A and the side across from it. So I'm first going to compare that to the other side. So since side A is bigger or longer than side B, there's only going to be one solution. So since A is bigger than B, there is only one solution. Only one solution. So what's going to happen here is we've got our angle A, we've got, so this would be angle A. The side A here is bigger, so this is side A, is bigger than my side B, so it can't create two triangles out of that. All right, next diagram here, or next situation here, we've got angle A is 32 degrees, side A is 8 centimeters, and side B is 11 centimeters. So our side across from our given angle, let me draw a picture for this one, just change the color here. Side across from the given angle is shorter than that other side. So if this is my angle A of 32 degrees here, the side across from it is shorter than this other side. It's shorter. So you could have potential for this happening or this happening. There's potential for two solutions, but we also have to check and make sure that it actually is long enough to make a side. So let's just check the B sine A. So we're going to do 11 times the sine of 32 degrees. And when we calculate that, we just want that to be smaller than 11, or sorry, smaller than the 8. And I'm just putting that into my calculator right now, and I get 5.8 approximately. 5.8 centimeters. So definitely it's bigger. Side A is bigger than this. So there will be two solutions. So since B sine 11 sine of 32 degrees is smaller than 8, but it's still smaller than the 11, there will be two solutions. There we go. There will be two solutions. All right, try the next two, see how you do on that, and then check your work. All right, I've got angle A in the corner here. So that's 58 degrees. And then we've got side A is 5.7, and we've got side B is 8. So my side A is 5.7, so it's smaller. Let me undo that. It's got to be smaller. And I didn't mean to make that look like, there we go, let's try that. So this is 5.7. Now, it's definitely smaller than the other side. There's potential for two solutions or potential for no solutions. We're going to check the B sine A kind of thing here. So we're going to go 8.0 times the sine of 58 degrees. Let's check and see what that's going to equal. I got about a 6.8 here, 6.78. So that side, 5.7, is not long enough to create a triangle. So since side A is smaller than B sine A, in other words, we've got 5.7 is less than the 6.8, that's really what we're meaning, no triangle can be formed. And there wouldn't be a solution there. So no solution. Okay, the last one here, we've got x and side x and y, so I'm just changing my lettering here. So we've got a 61-degree angle here, that's my x, and my side x is across from it, it's the 22.8, and this one I'll make my 26.1. Okay, so my 22.8 is smaller than my 26.1, so there's potential for none or two, so we're going to check the B sine A. So 26.1 times the sine of 61 degrees. And that's going to equal, I got 22.82, or 83 if I round it. So it's not quite long enough to create a triangle. Whoops, I don't have the letter A this time. I've got, since x is less than y sine x, no triangle can be formed. So there's no solution. No solution.